Okay, so yesterday, this is what we did. We solved equations with variables on both sides, and we kind of explained our steps. And we, normally we distributed, combined like terms, and when we got to this step here, right? When we got to the step where we had variables on both sides of the equal sign, we usually got rid of the one on the right-hand side. And then we would end up with a two-step equation. Sometimes that's not going to happen. Sometimes that's not going to be the possibility. And we're going to see what that means and what's going to happen. Okay? So let's go ahead and begin. Oh, I dropped my boat again. So what we're going to answer is the following. Write this down, please. How many solutions does an equation have? So, how many solutions does an equation have? That's a question we're going to be answering. Because it turns out that when we're solving an equation, there's three possible outcomes, and we've only been looking at one of those possibilities. So, let's write that down. There's three possible outcomes. So we're going to look at all three of those possible outcomes right now. So let's do an example of each one or see what they look like. So we're going to look at outcome number one, which is the one we've always had up until now. So this is going to be outcome number one. And I'll give you an equation that'll give us that outcome. Negative 4x plus 12 equals positive 4x plus 20. Okay, so write that down. Now, take a look at that equation. What do you notice? What do you notice on that equation? Anything? Can we distribute? Can we distribute any numbers? We can't distribute anything. Can we combine anything? We can't combine anything, right? Do we have variables on both sides? Yeah. We got negative 4x on the left and positive 4x on the right. Are they the same number? No, they look similar, right? One's positive, one's negative. In fact, they're opposite, right? But they're not equal. And because they're not equal, if I want to get rid of this positive 4x, what would I do? What would I use to get rid of a positive 4x? Yeah, let's do a negative 4x. And we're going to do that on the other side. Okay. And let's simplify. We're going to combine negative 4x and another negative 4x. Here they won't cancel though. They will make negative 8x if we add them up. Bring down the plus 12. On the other side, though, they will cancel, right? And that equals 20. So this is what we get. So far, this is actually looking like any other equation. Let's get rid of the 12. Okay. So I'm going to minus 12, bring down negative 8x. 20 take away 12 is 8. Divide by negative 8. And I'm going to end up with x equals negative 1. Okay, we ended up with an answer, which no big deal because guess what? That's what we've always gotten, some sort of solution. How many answers is this though? One solution. So we have one solution. And it is negative 1. The key though is we have one solution. We ended up with one answer. On today's assignment, that's the part we're going to be concerned with. Are we going to end up with an answer? If we are, it'll just be one answer, one solution. And that's the first possible outcome, that we get one solution. 90% of the time, that's what's going to happen, but not always. Okay? Sometimes other things are going to be possibly happening, so that's what we're going to look at next. Let's look at possible outcome number 2. Okay, so here we go. Outcome number 2. So the equation that's going to give us outcome number 2 is this one. 3x minus 3 equals 3x plus 6. Okay, write that equation down. And I'm going to ask you the same thing as last time. Take a look at it. We can't distribute, we can't combine, but what do you notice? You notice anything? Yes? Yeah, it has variables on both sides. Good. Let's be specific about those variables. What do you notice about them? The coefficients are both positive 3. Yeah. They're identical, right? We got 3x on the left side, we got 3x on the right side. Believe it or not, we've never had something like that in all the equations we've had, where we've had identical variables after you. At this point, we got to get rid of one of them. Say I want to get rid of this one. What's going to happen? We got negative 3x, and that'll get rid of it, but I got to do that on the other side. What's going to happen there? It'll go away there. Watch. Look what's going to happen. To solve this, I have to get rid of the variable on one of the sides. Say I want to get rid of it here. I'm going to put negative 3x. But remember, whatever you do on one side, you do on the other. So I got to put another negative 3x here. Yes, it will cancel here. It makes 0. It cancels. But it also cancels here. And we end up with this. On the left side, what do we have? We have negative 3. On the right side, we have 6. We end up with this. Negative 3 equals 6. What is that all about? Well, that's different. It's not an answer, right? It's not x equals something. In fact, it's just a math statement. And math statements are either true statements or false statements. Is this one true or false? False. If it's saying negative 3 equals 6, that's not true. Negative 3 equals negative 3 and 6 equals 6. So if you end up with a statement where all the variables go away and you end up with one number on one side of the equal sign, one number on the other, it's either going to be true or false. And if it's false, like this one, then what that means is there is no solution to this equation. Okay? So this is a false statement. And what that means is there is no solution to this equation. No number exists that's going to work in this equation. Okay? The main thing here is no solution. There is no number that would work. You give me a number, we'll plug it in. It's not going to give me a true statement. Okay? So that happened because of this. You end up with some false statement. Even if it would have been negative 3 equals positive 3. If it's the same number but different signs, they're opposites, they're not equal to each other. So it's not, it's a no solution. And every so often, today more so than others, that's going to happen. Okay? Any questions? Here's the third possible outcome. Outcome number 3. Okay, so in outcome number 3, I'll give you an equation like this. Negative 2x plus 7 equals negative 2x plus 7. Okay, write that down. What do we notice in this equation? Juliana? Both sides are identical. Not only were the coefficients identical, but the constants are too. Okay, and that's going to give us something different. Let's solve it. Okay, what should I do to get rid of this negative 2x? Positive 2x. But because we know we have to also do that on the other side, we got to do a positive 2x over here. And this is going to cancel, and just like in the previous one, that's going to cancel. And we're going to bring down whatever's left. We got 7 equals 7. Okay? Again, we got a statement. 7 equals 7. It's either true or false, and this one is true. This is a true statement. Whenever you end up, when the variables all cancel out and you end up with the same number on both sides of the equal sign, that's true. 7 equals 7. Negative 9 equals negative 9. 0 equals 0. If anything like that ever happens, like this, well, what we have is the following. There are infinitely many solutions. Because every number would work in this equation. Okay. We just shortened this down to infinitely many solutions. So what that means when you end up with a true statement is every single number you could think of, positive, negative, if it's as long as it's on the number line, you put it in for x, it would work. Okay, so we can end up with one solution, which is what mostly happens, no solution, and then infinitely many. Okay. All right. Any questions? All right. So the thing is, more than anything, you got to recognize when you see it. So we're going to practice that a little bit. Okay. So we're going to do the following. State if there is one solution or no solution, or I'll save myself some room. You guys familiar with the infinity symbol? Mm-hmm. Infinitely many. Solutions. Okay. And the cool thing is, once you see it, once you can recognize it, you don't need to keep on trying to solve the equation. Because in today's assignment, it's only going to ask you, okay, here's an equation. Is it one solution, no solution, or infinitely many? You have to decide what it is. Okay? So let's do this. Number one. Okay. Negative 5x equals negative 2x minus 3x. Okay, write that down. All right, at this point, I can't tell. So let's try working it out. So what you want to do is work it out till you can decide, make the best choice. So we have variables on both sides, but obviously there's no distributing. Xavier, write this down, please. Okay. Do I have to negotiate something over there? I mean, I can move you guys, so that'll fix this. So will one of you be moving? Okay. All right. So can I do anything here to solve it? Yes. Yeah, that would always help. Combine the like terms. Let's combine those. What are we going to get? Okay, let me bring this down because I didn't do anything with it. These two combine to make negative 5x. Okay, so at this point I got negative 5x equals negative 5x. Can we decide what the possible outcome is? Oh, I'm hearing no solution, infinitely many. If you're not sure, take it a step further. I want to get rid of the variable, add 5x, and add 5x. Cancels, cancels, right? But if everything cancels on one side, what number can I write down? Over here, if everything went away, what number is still there? 0. Same thing on the other side. I end up with 0 equals 0. And if it's 0 equals 0, it's true. This is true. Therefore, infinitely many. Solutions. Okay, so in this case, we ended up with infinitely many solutions. That little triangle with the dots means therefore. Okay. Okay. So we ended up with infinitely many there. Number 2. Negative n equals 5 minus n. Okay. Remember, if we can't see it right away, just do what you normally do to solve it. What can I do to solve this one? Can I combine like terms? Can I get rid of variables? Do I have variables on both sides, in other words?
Yeah.
Yeah, let's get rid of it. What do I get rid of? How do I get rid of this negative n? Positive 1n, so I just put positive n. Same thing over here. It goes away here, of course, which is what I wanted. But guess what? Negative n and n, don't they also go away here?
Mm-hmm.
So as we saw in the previous, if everything goes away, what number do I have? I got 0 equals 5. That's a statement. Is it true or false? This one's false. It's false. Therefore, what is a false going to be? It's going to be a no solution. Okay, so in this case, we ended up with something that makes no sense. It's false, so it's a no solution. Okay. Let's try number 3. Okay, let's do this. 4n plus 20 equals 3n plus 20. All right. So definitely no distributing, no parentheses, so we don't distribute. Can we combine like terms on either side? Yeah, nothing on either side that I can combine. I do have variables on both sides though, right? Yeah, we can get rid of 3n. Let's do that. Minus 3n. And minus 3n. Okay. So now, let's see what that gives us. 4n take away 3n. 1n. Is it okay if I write 1n as just n? I could do that. So I get n plus 20 equals 20. So at this point, can we just determine if it's one solution, no solutions, or infinitely many? What do you think? One solution? Why is it going to be one solution? Why do you think? Think about this. If I continue, will I get an answer like n equals something? If you can continue and get an answer n equals, in this case, 0, then yeah, that's one solution. So and for today, that's all you really got to recognize. I mean, I'll solve it all the way because it's just one step. I end up with one solution, and it's 0. If you can go all the way to solving it to some number, then you got one solution. I could say the solution is 0. Therefore, one solution. So this one was a one solution. Because I got just one answer, 0. Okay? All right. So let's just do a couple more. I wanted to make sure you saw one where you did have to distribute. Okay, so let's take a look at this one. So here we got 7 parentheses x minus 1 equals 7x plus 7. Now, we have to distribute, right? We got parentheses. Let's do it. Distribute the 7. Let's see what we get. We get 7x minus 7 equals 7x plus 7. What do you think? Is it going to be 1, none, or infinitely many? Like I said, if you're not sure at this point, continue solving. What should I do next? Get rid of the variable, in this case 7x, and then 7x over here. It cancels here, but I got opposites here, and those cancel. Okay, do you start to see when that's going to happen when you have identical variables on both sides? 7x on the left, 7x on the right. And then write down what's left. We got negative 7 over here, positive 7 over there. Is that true or false? False. They may be the same number, but they have opposite signs. So this one is definitely false. Therefore, there is no solution. Okay. So what we're looking for here is the false. Just end up with a conclusion that there's no solution. Okay. All right. We'll do a couple more. Number 5. Negative 15 plus 2a equals 4a minus 15 plus 1. Okay, let's see here. No distributing. Can I combine like terms? Over here, do you see that I can combine those? Let's do that. Let's put those together. I can combine minus 15, negative 15, and positive 1. What's negative 15 plus 1? That's going to be negative 14. So I end up with negative 15 plus 2a equals 4a minus or negative 14. These two combine to give me that. Okay. All right. What do you think? One solution, no solution, or infinitely many? Again, if you're not sure, just continue. Do what you know to solve this. I know that I should do this, minus 4a. And let's see here. I get negative 15. 2 take away 4 is negative 2a equals negative 14. Okay? So at this point, what do you think? One solution, no solution, or infinitely many? It is going to be one solution. What makes you think that, what makes us know that we're going to get a solution? Yeah, if I continue, right, I would get rid of this 15. I would get rid of the constant, then divide the coefficient. I would end up with a equals something. So this looks like everything we've done before today, right? So as soon as you reach that point, you say, okay, wait a minute, I'm going to get an answer here. You can stop and say, we've got one solution. You don't have to solve it all the way to that, okay? So at this point, I would say there is an answer, so there's one solution. We didn't end up with one of these statements like 7 equals 7 or negative 7 equals 7, okay? So this one is one solution. Eventually, we would get the answer. We don't really care what the solution is. We care about that we're going to get a solution. Okay? Okay, this is going to be the last one. Number 6. 14x minus 12 plus 6x equals 20x minus 8 minus 4. Okay. Got lots of stuff going on here. Can't distribute, but can we get rid of, can we combine like terms? Yeah, on both sides. We can combine like terms on the left and on the right. So let's just do that all together. Over here, we'll put together this 14x with this 6x. On the other side, we'll combine the minus 8 and the minus 4. So constants combine on that side. Okay. So let's go ahead and do that. Let's see. 14 and 6 makes 20x. Take away 12. I'll bring down the 20x. Negative 8 and negative 4 makes negative 12. Yeah. Look what's going to happen. Do you see how you have identical things on both sides? 20x minus 12 on one side, 20x minus 12 on the other. That's going to give us infinite solutions. Look, if I do minus 20x here and here, they cancel on both sides, but then I'm left with the same number on both sides. Negative 12 equals negative 12. Oops. 12, not 2. And that is infinitely many solutions. This one's true. Therefore, infinitely many solutions. Okay. So on today's assignment, this is what we're going to be doing. Okay.